First part of this video will cover piecewise functions. A piecewise function is just a function that is defined by two or more equations. So you see that's just two different equations. We're going to do two things with these piecewise functions. One is evaluate, which is just a matter of doing arithmetic. You have to decide which of these two functions to use when you're going to evaluate, and that depends on these parameters over here. So this says I want to evaluate f of 4. Well, I need to go into this function right here because this is the function you use if your x value is greater than or equal to 2. 4 is bigger than 2, so I'm going to plug 4 in here and do that arithmetic. 2 times 4 plus 3, 2 times 4 is 8, plus 3 is 11. So the function value for this function at 4 is 11. This one says evaluate f of 1. Taking a look at the parameter, I want to use this because this is the one you use if your x value is less than 2. 1 is less than 2, so I plug 1 in here and I just get negative 1. The evaluating is the easier thing you have to do. The harder thing is to graph these. This is the exact same set of equations that we had on the other screen. Now we're going to do the graph. To graph this, your best bet is just to use your old t-chart and pick your numbers, but you pick your numbers based on this information here. This says x greater than or equal to 2. So I'm going to use 2, 3, 4. I could use 5, 6, 7, etc. if I needed to. The reason I have a little star here on this 2 is because notice this says x is greater than or equal to 2. So that 2 really is going to be one of the numbers I plug in here and is part of my function. You may say, wait a minute, why are you using 2 over here? Because this says x less than 2. Well, 2 is not less than 2. Well, can you name the first number less than 2? You might say, okay, 1.9. Well, what about 1.99, etc.? So what I do is I go ahead and use the 2 right here, but I know I'm going to do something different at 2 on the graph, and you'll see what I mean in a minute. But I do want to do the arithmetic here because I need to know what's going on at that point. So let's do the arithmetic. Put 2 in here. 2 times 2 is 4, plus 3 is 7. 3 in here, 2 times 3 is 6, plus 3 is 9. 4 in here, 2 times 4 is 8, plus 3 is 11. Now, it's your choice. You could take these points and get them graphed, and then come back and do this arithmetic, or do all your arithmetic together and do all your graphing together. And that's what I'm going to do. Now, this is going into this equation because these are my numbers that are less than 2. I know that 2 is not strictly less than 2, but I am using 2 in my equation. So, put 2 in here, gives me negative 2. Put 1 in here, I get negative 1. Put 0 in here, it stays at 0. So going back to graph these points, over 2, up 1, 2, 3, 4, 5, 6, 7. And that does get a big old fat colored in dot because this was x greater than or equal to 2. That's why I'm using the star there to remind me that's it. I have to do a little estimating here. Over 3 up 9 will be about here. And over 4 up 11 is about right here. Now, yes, that does make a line, but our line has been cut off because we're only going to use the line from 2 on out. So when I connect this with a line, it goes on and on. It should be a straight line. I just have a hard time getting that drawn. Changing colors, coming over here to graph this, over 2 and down 2. But that is going to get an open circle because that's really not part of my function. Then I do over 1, down 1, and 0, 0. So this is a line or part of a line, and it's going to go in this direction from my open circle heading up that way. Those are both supposed to be straight lines. I just have a hard time getting them drawn with this tool. Important thing here is that this gets the colored in circle because this was where I had put my star because that's where it was greater than or equal to 2. Since this is just less than 2, it has to have the open circle. And the reason that's important is you should remember that a function cannot have 2 points along the same vertical line. This would fail the vertical line test if this were a colored in circle. That's why that has to be an open circle. And specifically, that one has to be the open circle one because that just says less than 2. Let's take a look at another one. Back to doing plain old arithmetic. This says f of 3. Which one do I use? This one right here because this is the function you use when x is greater than 1. Well, this just says f of x always equals 4 if x is greater than 1. So this is just 4, no arithmetic necessary. This says f of 1. Well, I need to use the one that says less than or equal to 1. Plug your 1 up here and you get 3. So that's the arithmetic. Let's take a look at the graph doing the same thing. I have chosen my numbers because this says less than or equal to 1. 1's the first thing I'm putting in my chart. I'm putting a star on it to remind me that it's going to get the colored in circle. And then these numbers I've chosen because these are less than 1. Over here, I want to use x greater than 1. That's going to get the little open circle when I put it on the graph. And then the numbers greater than 1, of course, 1, 2, 3, etc. Now it's time to do the arithmetic. So put 1 into this equation. 1 plus 2 is 3. Put 0 in. 0 plus 2 is 2. Put negative 1 in. Negative 1 plus 2 is 1. Now on this one, I don't really have to do any arithmetic because this says f of x is always equal to 4, meaning the y value is always equal to 4 for these values of x. So just put 4 down on all of these. And all we have to do is graph. I'll go back to the first one and graph it in red. So over 1 up 3 with a dot, over 0 up 2, over negative 1 up 1, and that is my line. Now, you just don't automatically send it up to the right. The reason it's going to come down this way is because we're looking for the values where x is less than 1. So it's going to have to go this way. And you could convince yourself if you wanted to by picking another number or two. Put negative 2 in. Negative 2 plus 2 is 0. So over 2 up 0, we landed right on it. Switching colors. To do this one, everywhere my y value is going to be 4. At 1, we're up at 4 with an open circle. At 2, we're up at 4. At 3, we're up at 4, etc. This is just going to make a horizontal line, beginning there, heading off to the right with my open circle there. So that one gets the colored in circle, that one gets the open circle. All right, this next one we're just going to graph. The arithmetic is easy when you're just told to evaluate. It's the graphing that deserves another look. Also, the other two equations always gave us lines. This is not going to give us a line. You may recall from 1033 that if it's got x squared in it like this, it's going to give us a parabola. Our parabola is some sort of curve, either facing this way or this way. So we're going to plug into here. This says x less than 1. It doesn't get the little star on it because I'm not going to use a colored in circle on it. But I am going to put it in here so I know where to start with my y value. So 1 squared is 1. Negative 1/2 times that is negative 1/2. This is the chart for less than 1, and that's why I've gone from 0, etc. Put 0 in here, it's just going to give me 0. Now you may wonder why I went from 0 all the way down to negative 2, and that's just to make my arithmetic easier. Negative 2 squared is a positive 4. Negative 1/2 times 4 is negative 2. That way, I have avoided another fraction. It's just easier to graph that way. And then I've jumped down to negative 4. Negative 4 squared is 16. Negative 1/2 times 16 is negative 8. Reminder, anything squared is positive. That's why when I said negative 2 squared, it came out positive 4. They're equal to 1. So I start with 1. I put a star on that, knowing that this point is going to get my colored in dot. Back to this one. This point will get my open circle dot. Do the arithmetic. Put 1 in here. 2 times 1 is 2, plus 1 is 3. 2 in here. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. And 2 times 4 is 8, plus 1 is 9. Graphing this one in blue, over 1, down a half. I have to fake it a little bit. Over 1, down a half is going to give me a dot right here, but it needs to be an open circle. It's a little bigger than necessary, but that's the best I can do on that small graph. 0, 0, negative 2, negative 2, negative 4, negative 8 will be about right here. And remember what I said, we know this is going to be some sort of parabola. It's actually just going to be part of the parabola. So this is coming up, and it's going to come back down with an arrow on there because it does continue out this way. Don't think about it continuing down. It's continuing out left because these are the numbers that were less than 1. Switching colors to red. Over 1 up 3, getting the colored in dot there at 1. Over 2 up 5. Over 3 up 7. And 4, 9 is about up here somewhere. And these are the numbers getting greater than 1, which means it needs to send out to the right. So here's my line from there with an arrow on the end because it continues out to the right. So that's your piecewise function, both evaluating and graphing them.